Hello, welcome back to Software Requirement Engineering, Solution-Oriented Requirement, Part 2. In this part, we are going to focus on one of the three perspectives. What are the three perspectives in solution-oriented requirement? Number one is data perspective. Yes. Number two, behavioral. And finally, functional perspective. In this lecture, however, we're going to look at only data modeling. Data modeling is used to specify static aspects of the system. The static aspect of the system encompasses entities and the objects, the relations between the entities, and attributes that explain about the entities as well as the relations. Look at the figure below. On the right hand side, there are 4 layers. Let's begin with the lowest layer, concrete objects. Concrete objects are example objects that we can identify from scenario. These concrete objects have individual identities such as names, matrix number, etc. Concrete objects serve as examples that we can analyze. When we analyze, we identify the class type of the concrete objects. This will help us to identify the entity that we can use in the data model. Using the library loan system as an example, we have many library users. In this example, we have Joe, Fred, Lisa, and Zoe. They are all library users. Joe, Fred, Lisa, and Zoe, they are concrete objects. They are examples, which we can group them together as library user. At the library, there can be many titles. There can be titles such as National Geographic, Nature, Fortune. These are magazines. We also have titles such as The Great Expectation, Crimson Tide, Lord of the Rings, Harry Potter. These are titles of books. So, we have just identified from the concrete objects 3 entities, which are library users, magazines, and books. Now, these entity types will be captured in the data model, not the concrete object. We want to capture the entity types in the data model. And the data model can be recorded using certain notation. We're going to study 2 modeling languages, which are Entity Relationship Model and UML Class Diagram. Let's begin with Entity Relationship Model. Entity Relationship Model is commonly used in software engineering. You are probably aware of it from database classes. In database classes, you probably have used Entity Relationship Diagram to draft the structure for the tables to be used in database. Well, Entity Relationship Modeling and Entity Relationship Diagram are both the same thing. Let's look at the symbols used for entity relationship modeling. As I mentioned, entity relationship modeling is used to capture the entity type and the relationship type. So the entity type is represented by a rectangle, relationship is represented by a rhombus. Attribute can be represented by an oval. Sometimes we don't put an oval, we just simply spell out the attribute name. And we can actually specify the quantitative relationship, the quantitative quality of the relationship by spelling out the cardinality, which are range of possible numbers for the relationship, and the row name in the relationship. Sounds confusing, huh? Never mind. Let's look at an example on in the bottom right of this slide. Let's look at this example. In this example, we have 2 entities, which are library user and book. The relationship between them are borrows. So we draw lines and the relationship rhombus between the two rectangles. To enrich the relationship information, we can spell out the row name and the cardinalities. In this case, library user is serving the row as a borrower, and the book is serving the row as the borrowed item. Now let's look at the cardinality. The cardinality is actually a number. If we have a range, then we put the numbers, the two numbers, the min and the max, within the brackets. In this case, a library user can borrow 0 book up to maximum 20 books. And for the book, it can have no library user borrowing it to maximum only one library user borrowing it. So it's a range. Moving on is more examples illustrating entity relationship modeling. Now, this first quadrant is just showing us the entities, not very informative. The second quadrant is showing us entities with relationship, and the relationship has row names for each of the entities, more informative. Now, this is still not sufficient. For the library user, we may want to capture more information, more properties, in which case, let's look at the attribute quadrant. We need to capture properties for the entities, right? So, we can have, for example, matrix ID, first name, and last name for the library user. How about books? In this example, we don't show any attributes, but you can guess what they are. For example, the title of the book, the author of the book, the publisher of the book. Can we have attributes for relationship? The answer is yes. Sometimes some relationship will need to have more information. For example, when somebody borrows book, we need to capture information such as the starting date, the period of how long the book can be loaned, and the return date. So these properties do not belong to library user, they do not belong to the book, but they belong to the relationship which connects the two entities. Now let's look at the last quadrant, which is relationship types. Typically we have binary relationship, which involves only two entities. Binary stands for 2. In this case, student attends lecture, we have only two entities connected by one relationship. Sometimes we can have ternary relationship types. Ternary meaning 3 entities for one relationship. In this case, a company sells a product to a person, involves 3 entities in one relationship. Rarely, but sometimes we do have reflexive relationship type. For example here, if somebody marries somebody, we can draw person married to person. In this case, the first person may be the husband or wife, and the next person is the wife or husband. Now it looks a bit confusing since marriage often involves 2 persons, but in the drawing only see 1 person. Bear this in mind, in ERD we are capturing the entity type, not the concrete objects. We are capturing the entity type. Yeah, of course we can have entity wife and entity husband, wife married to husband. Alright, in that case it's binary. But if we only define person as the entity, then this reflexive relationship is correct. Let's move on to the next slide. The next slide is focusing on cardinality constraint, which I mentioned earlier. Cardinality actually provides the quantitative property of the relationship. In this example, a library user can borrow 0 to 5 maximum number of books, and each book can be loaned by no library user or maximum only 1 user at a time. So it is a range. Yeah, in the bracket there are 2 values, the min and max. But you can also have 1 number sometimes. Now there are 2 popular notations here. One is ISO notation, the other one is chain notation. These two always cause confusion because of the way of the different order they arrange the cardinality. ISO is using same side cardinality. Now in this case, a person is born in only one place. So this one place refers, one and only one refers to the location. Yeah? One and one refers to the location. Now, in chain notation, it uses look across cardinality. In which case, a person, any number of person, yeah, can be born in only one location. So we have to look across. One person, any number of person can be born in any one location. So you have to look across to figure out, rather than looking at n, we have to look across to the other side of the relationship. In this case, 1. So a person is only born in one location, and a location, in one location we can have many people born in that place. Now, if you had used ISO, it would have been the opposite. Yeah, if you use ISO to define this example, it would have been a person can be born in many locations, and each location can only have one person being born. So that's the difference between chain and ISO. My preference is chain, so it's a matter of preference. So we are done with entity relationship diagram. The other popular diagram will be class diagram. Class diagram make use of classes and association. In this case, we have one library user entity as the class. Another class is book class, which represents the book entity, and the association relationship borrows. Again, we have cardinality. Here it seems like we're using look across, right? We're using something similar to chain. Library user can have 0 to 20 max books, and each book can only have 0 to 1 library user. So it's look across, not same side, similar to chain. The relationship is represented by a line. If you look at the example here on the right hand side, a library user borrows 0 to 20 books, and this class is what we call association class. It's not entity class, it's association class, because the class defines the association relationship. So it spells out the return date for the loan of the book. So these are the notations of class diagrams. Alright, we have association class, which defines the property of the association. We have aggregation relationship, we have composite relationship, we have generalization relationship for indicating subclasses of a superclass. Let's look at an example. Let's look at example to make sense of them. Okay. I think I've explained the first example here. Alright. Now here is showing aggregation. A course can have 0 or many students, but we can have a course without any student. That's why it's called aggregation. For composition, a series will have many volumes of book, and you cannot have 0. So composition is like aggregation, but you must have at least 2. So that's the difference between aggregation and composition. And a generalization shows a class which is more specific. Like textbook is a book, dictionary is also a book. Now this generalization text shows you the constraints for this subclass, which I don't plan to explain further. You can read the slide. You can pause and read the slide. So that's it. That's all for data modeling. Before you complete reading the lecture slides, why not try out these questions to see whether you understand. Thank you.